Science Basement!
Hello and welcome. You are listening to the Science Basement podcast, a podcast for people who love all things science. I'm your host, Pratakshi.
And I'm your co-host, Katja.
And today we have Helena Hartmann with us. Helena did her PhD in social neuroscience from the University of Vienna, Austria, and is currently working as a postdoctoral researcher at the University Hospital Essen in Germany. She's intrigued by the factors influencing the perception of pain in both oneself and others. She employs various neuroimaging, neuromodulation, and behavioral experiments in her studies. In addition to conducting research, she's an avid science communicator and actively participates in and teaches science communication. Welcome to the podcast, Helena.
Thanks both for inviting me. I'm very happy to be here.
We're very happy to have you. So, Helena, you work on pain, right?
Yes.
Can you tell us briefly what pain research is and how long has it been going on?
Yeah, I think it's been going on forever, at least as long as I can remember, to be honest. Of course, research started with animal work, and with animals, you can actually do a lot more than with humans, which is probably a good thing. But I'm a human researcher. So when I think of pain and pain research, I think the first thing that comes to mind is the Milgram experiment. That's a very famous, unethical psychological experiment where people got lots of pain and had to deliver pain to other people. It's highly criticized now, but that's what I think of whenever I think of like prior pain research.
Can you briefly remind me what that experiment entailed?
Yeah, so basically it was about obedience to the experimenter. So there was a participant who was instructed to do like a learning task with another alleged participant. And that second one was actually an actor. So it wasn't a real second participant. And then when the second participant didn't get things right in this learning task, the participant was supposed to deliver shocks, painful shocks to the other person. And whenever the participant felt like he didn't want to anymore, the experimenter would just go, please continue. So it was basically tested whether the participants would just stop and cancel the experiment, like stop the experiment, or whether they would continue. And the study found that many people would be obedient and just continue to give shocks to another person, up to deadly shocks. So even if they heard noises coming from the other that indicated that it was very bad for them. But that being said, this is one experiment. It was done once, and I don't think it was ever replicated. So it wasn't found again the same result. So, and of course, we don't do pain research like that anymore nowadays.
That's very good to know. Yeah, I feel like I've seen these videos online. It's probably like the acted out version of the replicating the experiment, or to like act it out. And there's just this video where the guy's like, oh, please stop. Like, it's so painful. Yeah. And then it goes like silent. And the other guy is like, so I keep shocking, even though he like maybe died.
Yeah, and I think now we can like laugh about it a little bit because it feels very ridiculous that people would do that. But those experiments were quite common because I think instances like ethical committees were not that much in place or were not used that much as they are nowadays. Like now every study that we do in psychology has to be discussed by an ethics committee before and has to have received approval from that committee before we even can start doing anything.
Yeah, that's good that we've come so far in our social neuroscience arena. So what are you researching at the moment? And I hope it's not anything related to the Milgram experiment.
Oh, it actually is, but far more ethical. But I mean, so in my PhD, I also did a lot of pain research. I was always interested in the interaction between cognition and pain. So how what we think or expect or feel influences how we perceive pain later. So, for example, if I tell my participants that they will get a treatment that relieves their pain, for example, a pill or a painkiller, and then I put them in the MR scanner where I measure their brain activity, I can see what happens in their brain when they expect the pain relief. So when they think they're under a treatment where they will feel less pain, and then I can look in their subjective responses, so how they rate the pain, but also in their brain activity, in their a bit more objective brain responses, what happens in the brain when they feel pain under different conditions.
Okay, so that's really cool that also, depending on if they think they're getting the pain medication or if they know that they're not getting the pain medication, that this could actually affect like the brain imaging itself. And clearly the role of expectations is there seems to be a role for expectations in the results.
Yeah, definitely. And expectations is also what I'm mainly focusing on in my research now in the postdoc. So for everybody who doesn't know what I mean with expectations, we can also call it a little differently. We can call it placebo and nocebo effects. So placebo effects are reactions to non-pharmacological or inert treatments. And for example, if I give someone a sugar pill and I tell them that now you will get a pain medication that will make you feel less pain, in that case, that is a so-called deceptive placebo. So I'm not telling the participant or the person that what they're actually getting is a sugar pill. But we also have open label placebos where people actively get told that what they're taking is basically inert, but it has all these good properties of the placebo effect and the way that expectations work. So they're really trying to communicate these effects in a more honest way.
So if they know that it's just a sugar pill, that expectations factor is kind of taken out from the equation, right? So then why does that work out?
It's taken out in one sense, but not in another, because basically what we tell them is, here you're going to take this pill. It doesn't have a pharmacological ingredient, but if you think positively and if you expect something to help you and to make you feel better, that is still causing expectations, and that is still leading to changes and change feelings basically down the road.
But then why do they need to give a pill? They can just like give other methods, like, I don't know, some breathing exercises or something, and like just the power of thinking that if you think like that, your disease is going to go away. So what is that pill contributing?
No, that's completely correct, because I think when people think of placebos, the first example that comes to mind are sugar pills. That's why I always use it. But in fact, you're completely correct that placebos is like an umbrella term that can be literally anything. So it can be a treatment, it can be breathing exercises, it can be movement, The only thing that you have to be aware of is that if you go in the direction of, let's say, yoga, for example, or taking supplements or drinking tea, that is not super inert anymore. So that does have a component to it. Either you do physical exercise or you're taking something inside your body, right? So it's a bit tricky to distinguish it, but I think we can define a placebo as something that is not being used for a certain purpose. So if I give you breathing exercises against your pain, that is not like a painkiller that would pharmacologically actually help the pain, right?
Yeah, that makes sense.
And it's actually, the placebo question, I guess, comes a lot. So in our lab, we research psychedelics, and there's a issue actually, or one of the issues in the field of psychedelics, especially on the human side of things, is that people have an expectation that, oh, this will definitely work for me. I've read a lot about it. And it's like, how do you, it is something that we struggle with in the field, because people know to expect perhaps some hallucinations. And if they're not getting it, they're like, oh, well. And then they immediately assume that they will have results if they do get the hallucinations. So it's really cool and important that your research that you're doing.
Yeah, I think a major point that you just mentioned is that placebo effects are not only related to fake treatments, but they can also make real treatments work better, for example. So if I give you a painkiller and I, together with the painkiller, I tell you, I have made very good experiences with this one, it will definitely work on you as well. Your whole mindset of going and taking that medication is a completely different one. So you might already have on top an additional positive expectation that might lead to the medication actually working better. And I've heard anecdotes from patients here at the clinic saying that sometimes they take a pill or a new treatment and it immediately works. Like, even though pharmacologically it needs a few minutes to get into your bloodstream and your brain and work its magic, it works immediately. And I think that is to a big extent due to the expectations that people have.
That sounds quite good, I guess, in some cases, though. You also mentioned a nocebo, though. What does that mean?
Yeah, you can imagine a nocebo as the evil twin of the placebo. Actually, there's no such thing as a nocebo. There is a nocebo effect. And that is because a nocebo effect is also based on something inert and fake or sham. But it goes in the opposite direction. So instead of the thing giving you a positive expectation, it's giving you a negative one. And the best example for this is side effects. So if we take something and our neighbor told us that they got really strong stomach cramps from that, or I think something everybody can relate to, you take a new medication, you look through the package leaflet, you look at all the side effects and they're all listed, and it looks really scary, to be honest. And then you're just like, oh, what if I get headache? What if I get nausea? All of these things. And just because you're made aware of that kind of fuels your negative expectation, and the likelihood that you actually develop some of those side effects increases.
Yeah, and I feel like you're always so much more aware of what's going on in your body when you read those long lists of like bad side effects in a way.
Yeah, my boss here at the clinic, she's always very conscious of saying that we need to think about how the information in the package leaflets is perceived by the people reading it, and how we can make it more positive in a sense, but without hiding the side effects. Because ethically, you need to inform people about the side effects of different medications, right? But there's different strategies, and there's different things being researched. For example, positive framing. So the way that you present those side effects, for example. So instead of saying 2 out of 10 people develop headache, you could say that 8 out of 10 actually take it quite well, so they don't have any side effects. And that kind of reframes it in a positive way, even though it's the same information.
That's interesting. But like, do you think some pharma companies might misuse this positive reframing to advertise products, which might not be good for the people, or, might actually cause more harm than good?
Yeah, that's a good question. I think that, pharma companies, I guess, want to promote their medications, and they want to put it in the best light, but they also need to inform. So I think there's always this like small print in advertisements that you see on TV or on screen, where you have like small print for risks and side effects, please check the leaflet, or ask your pharmacist or something. So I think it's every person's own responsibility to, inform themselves previously, but it also depends a lot on your personality and how you take in this information. Like, there might be people who might be a bit more anxious about developing side effects, right? And if they read these leaflets and this information, they might react completely differently as to someone who's like, yeah, okay, it's good information, but it actually looks like it doesn't appear very often, so I won't worry too much about it.
Yeah, we are very individual after all.
Yes.
Yes. So moving to your work now, like now that we have the definitions in place, how do these definitions apply to your work? What do you do?
Yeah, so I work with expectations. So I'm all interested in what happens in the brain when we expect certain things to happen or not to happen. So in experiments that I'm doing now, people actually get a treatment, and sometimes this treatment increases their pain, so they feel more pain, and in some other options they feel less pain. And then I look what's going on in the brain. So I measure brain activity using magnetic resonance imaging. That is basically just a big magnet that people get thrown into. Not thrown, like driven into. I don't know if people have seen this like big bore, like a donut that you go inside.
Yeah.
That's an MR machine.
Yeah.
And it's a very complex method, but very cool because it's not painful. The only thing that is really annoying is that it's very noisy. So you have to wear earplugs, and we have to put like blankets on top of people because it's quite cold. The magnet, because it's so big, has to be constantly cooled by liquid helium. So the room is very well ventilated, I would say. So lots of blankets and lots of ear protection, and then it's okay.
I remember I had an MRI one time, and like those were the two things I could remember, that it's so loud and I got to choose a radio station to listen to, and then that my feet were freezing and I wished I had worn like woolen socks or something.
Yeah, we have like a blanket in place just for that, and every time we ask people, and some people in the beginning say no, it's okay, but then after like 5 minutes they're like, yes, give me the blanket.
Yes. But so you play with you research the expectations, but presumably then, since you are researching pain, you induce pain in the patients as well. How do you induce the pain?
Yeah, so right now I'm actually not testing any patients. So under patients, we usually define people who have a neurological clinical condition. Right now I'm doing research on healthy or neurotypical participants. But the pain induction is basically the same. So we do lots of studies with different pain modalities. So in my PhD, I was doing a lot of electrical pain. That is the famous electric shocks, but they're very short. They're painful, but they also last really short. So they're over quite quickly. And now in my postdoc here at the lab in Essen, I'm using heat pain. And this is completely different. So electric pain is transmitted over like a really, really small electrode on the hand, while thermal pain, you have a so-called thermode that is a few centimeters by a few centimeters, like a square, and that is put on the skin, and this heats up. It's like a tiny plate. And the heat pain is usually much longer that we give. So it ramps up and then it stays on a plateau for a bit and then it goes down again. And I think the stimulations that I'm giving are 20 seconds long. So those are quite long pain stimuli.
Yeah, if I had to choose, maybe I'd take the quick.
Yeah, like give me the quick pain.
Yeah, I don't know. I mean, you also get used to the heat pain. People who apply to my studies are usually fine with receiving pain. I think that's quite a selected sample of people. So we don't get people who actually don't want to feel the pain. And it can be quite unpleasant. And I think it's just a different pain experience. While the shock is very like a pinch, can be quite unpleasant. The heat pain is like you feel it building up and then it goes slowly down again.
I was wondering, like, how do you get past the ethics committee? Because for human experiments, it's a lot harder to get ethics approval. So, like, for especially something which will cause pain, how do you get around that?
Yeah, so I have been quite lucky because in all the labs that I've worked in, pain experiments have been quite a tradition. So that means that they have a lot of experience with getting ethical approval for pain studies. And there's a few things you have to take into account. So there's the informed consent. So you have to tell people before how many shocks they're going to get, how painful it's going to be. Second, we are making sure that we calibrate the pain individually per person. So that means that we basically check until what level the pain is tolerable. So it can be very unpleasant, but it has to be tolerable. And we have like an end of the scale where we say, let us know if you get a stimulation that you would not want to receive again in this experiment. And that is kind of the pain like threshold, I would say. And we don't go over that. So what they do get pain in the sense of something that doesn't feel very nice, but it's always in a range where they can still tolerate it. And I think that's really important for the ethics committee as well, to make it tolerable for people. And the third thing is that people can stop the experiment without letting us know of any reason at any time point. So, and we repeat this, like we say it in the beginning. And whenever I see that people are a bit nervous, I say that, how do you feel? I ask a lot also during the scanning session, because it's very sometimes weird for people to lie in a dark room and just hear a voice, like me speaking to them through the intercom. So I'm trying to create like a nice atmosphere so that it's manageable. But they can stop, and that's fine. And we've had a few people saying that they don't want to continue, and that's fine.
Yeah, I guess there's a bit of a dichotomy because you have to create this nice, comforting, relaxing atmosphere, but at the same time, it's like, there's these interjections of pain.
Yeah. And I mean, sometimes I have people being like, oh, this is not like the Milgram experiment. We had it about that already. And then I'm trying to be very clear that it's different. And of course, we're researching pain, but it's all very controlled and done in a very clean way.
And it's such an important topic because a lot of people do suffer from, pain. So somehow we have to learn more about it and how it works. So how do you actually measure the pain and analyze the data? You already mentioned the fMRI scanner, but how do you measure it itself?
Yeah, there's different ways, and usually we like to have a combination of many, just because measuring one thing one way can sometimes be a bit biasing. So we're not sure if we're actually getting there and measuring what we want. So usually what we do is at least 2 measures, one subjective one. So we just ask people, how painful was the stimulation for you? And then they answer it on a rating scale, a visual analog scale from 0 to 100, for example. And 0 is not painful at all. And 100 is very, very painful. And then we supplement that with some more objective measures. So I have measured skin conductance in the past, heart rate, or also brain activity to see what goes on in the brain. And that can be used kind of in combination next to each other. So when I publish my studies and I analyze my results, I look at all of these measures in unison together and see whether it's comparable. So ideally, people report higher subjective pain, and then regions in the brain would also be more active in comparison to a condition where they would report lower pain.
It's really interesting. So you mentioned that you don't work with patients and typically work with normal participants. So why would anyone want to sign up for that? Like, how do you usually recruit people?
Yeah, that's a good question. There are actually times of the year where it's very hard to find participants, usually in the summer when everybody's gone. But many, at least I can speak for psychology and medicine, many of these experiments draw on the student population. So since we also always pay a little bit of a little compensation for participating, I think that's a big enough incentive for students to earn some money on the side.
An interesting side hustle.
Yeah, I mean, we mainly get students, but we also try to be a bit broader. Like I try to get students from many different fields so that it's not very centered on one student population. But usually you test people between, I would say, 18 and 40 years old. That already limits it quite a bit. And you have to exclude some people because maybe you have specific in- and exclusion criteria. And then not many people are left over. So for the healthy neurotypicals, we have a database in our lab of people who have participated in the past. And usually if we're out of people, we just contact some of those to see if they want to come again. But we also don't want to test them too many times after each other because we don't want the experiments influencing each other. So one rule we have, for example, is that you have to wait 6 months before you can participate in another experiment.
Yeah, that sounds good. I guess otherwise you'd have the same pool of masochistic people coming to your
They would know
studies,
what to
perhaps.
expect, so that might skew the data as well. Like if the same participant are coming again and again.
Yeah, definitely. You want different, fresh people. And I always like it when there's people who've never done a study, because then I always feel it's my responsibility to make sure that they feel like that's actually a cool thing to do. So I'm like, I'm trying to make it a good experience, even though it's a pain study.
And so what does your research actually mean, and what are some of the direct applications?
Yeah, with basic research, that's always a very mean question to ask.
Yes, I'm sorry. It has to be asked.
No, it's fine. I think it's very important. And in my PhD, I actually had quite some trouble to identify real-world applications. I was researching empathy and how we perceive the pain of other people and what prompts us to help people, so pro-social behavior. And I was just looking what's going on in the brain if we see other people in pain. So I was just researching the basic mechanism of empathy. But of course, you can always say that social processes are really important, and it's really essential to find out how we process others around us. so that we can maybe in the long term come up with therapies or things to increase empathy and helping behavior in the society. But that's very like far stretched, right? Long time before before my research directly applies. So I always had trouble with that. And then I started my postdoc at a clinic, so a university hospital. And then I was just amazed how many direct applications my work now has all of a sudden. So I research expectations, placebo and nocebo effects, and this is directly applicable to the clinic and to patients who come in with their expectations and they react to new treatments, and this influences the success and the efficacy of those treatments. So that's really cool. And I think that also makes my research even more fun, because I know that it might actually help people not only in the long term, but maybe potentially short term as well.
Yes, I imagine it must be very rewarding to immediately, see the positive effects that your research is having.
Yeah, and some people in my lab also do research on patients directly, and that is even cooler, I think, because then you really research, okay, what goes on in the brain of people with chronic pain when they have positive expectations. Can we try to decrease their pain and their suffering, basically?
And so chronic pain, for our listeners who might not be familiar, I guess that's like the feeling of feeling pain all the time. Is that correct?
Yeah, exactly. So we distinguish between acute pain is something that has a warning function. You put your hand on the hot plate and you're pushing it back immediately. So it's warning you that is dangerous. It's going to cause tissue damage if you don't remove yourself from it. That is acute pain. But then if this pain becomes persistent and there's criteria how long, a few months it has to stay, if it doesn't go away and if it significantly affects your life, your functioning, the way that you work, interact with people and so on, then that develops into chronic pain. And my lab here is actually also, so my boss is the head of the pain center at the clinic, and she deals with a lot of these chronic pain patients. So that can be migraine, for example, or chronic low back pain, but also fibromyalgia. And those all are like belonging to the chronic pain consortium, which is very huge and very big, many different things that could be classified as that.
It indeed is very cool, the work that you're doing, because I've had some close people in my life who have suffered from chronic pain, and it's really nice to see that people are working towards the betterment of their life. So are you looking forward to working with patients as well? Because right now you're working with neurotypical people.
Yeah, I really am. I think that's super fascinating, but I'm also a bit scared a little bit. So I luckily have colleagues who have a lot of experience with that. So I hope that I can kind of watch them doing it and learn in the process, because I think if you're working with patients, you have to be a lot more careful, because it's a very vulnerable population. So I think a very good example is we do these long sessions in the MR scanner. People lie on their back for an hour, up to 2 hours. And if you have patients with back pain, that is kind of contradictory, right? So you really want to try and minimize the pressure on them and make the experience as helpful and positive as possible, while at the same time getting all the data that you need, that you want, right? So it's very tricky, I think, and there's a lot of things to take into account. In my completely different topic, but in my master thesis, I was already working with patients, but with people with autism spectrum disorder. And that is also a very interesting population to do research on and to do research with. And I've had people who actively want to promote autism research. So they participate in studies because they're so interested that other people do research on autism and try to find out what's going on, what's maybe different in their brains. So I think it's cool to have people who support the research as participants.
Yes, I definitely think without the participants, there's no science or research without them. So we need them all.
Yes.
As a researcher, what does your daily life look like?
Well, many people might think I just run around, which I do that, and I do experiments all day. Not sometimes. I sit on the computer a lot. I read a lot, which is just publications of others. I write. I do data analysis, and that all is in front of the computer. Sometimes I also write grants, so I need to get money for new experiments from funding agencies. But right now I'm in my active testing phase. So apart from being on the computer, I do experiments. So that means that every second afternoon or so after my workday, I go down to the, I'm on the 4th floor, I go down to the basement and to the MR scanner and do experiments. And that's really a good kind of counterweight to all the computer sitting. And I actually quite enjoy it. And I have very capable students who help me to do the experiments. So I'm not by myself. And it's nice to interact with people and participants who are interested in your research.
That is really cool. And I'm really looking forward to reading the papers and your work. But we all know that apart from doing science, it is also important how we communicate it. So, and as I mentioned, you are a science communicator. I have been following you for quite some time now. How did you start out?
Yeah, I think I started around the beginning of my PhD because there was just an email, innocent email, like, oh, there's the Children's University or the Long Night of Research, and they're asking PhD students to contribute. And I was like, oh, that sounds fun. And I think after those small events, I was basically hooked. And I was like, this is amazing. Like, people are interested in what you're researching, and I can also learn about communicating my research better to people who have no idea about it, but who are like super interested in it actually. So first I did it together with my colleagues, like these small events. And then I started writing some articles for public outreach magazines, for example. I was doing other events and kind of working on infographics and podcasts and different other formats of communicating science, and it was all super cool. And for me, I mean, it has a direct benefit in kind of two ways. I explain my research to other people, and they're really interested. They want to listen, they want to learn, but also I learn a lot about myself and my research. Sometimes people ask questions I would never in my life have come up with myself or asked myself. And that is really cool because it makes you question things and not take things for granted and put it in a different light, what you're doing.
Yep, and you definitely see everything from a new angle, as you said.
Yeah.
And it can make you, I've often also noticed that you can kind of understand your own work better through these different lenses. And it's like, oh, wow.
So when you're in academia and you're surrounded by your colleagues, you use all these jargon and all these technical words. So you're in like a bubble. And so I think SciComm gives us this another perspective when you're trying to explain your science to a layman. And it kind of makes you question your research and like why you're doing it, and kind of puts things in a different makes things kind of makes you look things through a different lens. So that is something that I feel is really cool. Something which
I think that like scientists are sometimes very obscure profession, like nobody knows what they're doing in their labs all day. But I think it shouldn't be like that. It should be like an open door. Science is for everyone, and everybody who wants to learn about it should be able to. And I mean, not every scientist has to be a science communicator, but I think it's a very important middle group of people who can do science, but also communicate about science, so that all the fantastic results and interesting things we study and we find out, they reach beyond the academic tower in the world, basically.
And it's so important to let the general public in this community, because then they are the ones who make the decisions and kind of impact the world.
And it's like, ultimately we get really cool results and we find this cool knowledge, and it's funded often by taxpayers. So it makes sense that, hey, let's share this cool knowledge that we do find.
Yeah.
And you've got an interesting SciComm project going on. Wondering if you could tell us a bit more about that.
Yes. So the project is called Science and Fiction, and it's actually something that I kind of developed during the pandemic a little bit, because I realized I have all this free time and I actually enjoy creative writing a lot. So I started writing some short stories just for myself, and then I shared them with friends and family, and they really enjoyed them too. And I always wanted to kind of combine this with science communication in a way. And I was really thinking a lot about how I can, on the one hand, have fictional stories, and on the other hand, talk about real science that has been done, that has been published. And that's basically how the project started. And I thought that I could use short stories as kind of an entry point to get people interested in the topic, because they like to read, because they are interested in storytelling, but then also lead them to a certain scientific result or a scientific publication that is related to the story in some way. And this way they're kind of, they get the entry, the doors open, and they're also learning about science at the same time.
Exactly. The story kind of functions as like a hook to capture people in.
Yeah, exactly. And so for the project, I basically write short stories, and then for every short story, there's a scientific publication related to the story, and there's an easy to understand summary of the paper and the results and how they relate to the story, so the connection kind of. And in the beginning, I've written a lot of the stories myself, and now I've also opened it up to the scientific community, because I thought I can explain psychology stuff, but maybe not any other discipline, maybe neuroscience, yes. But there's lots of other disciplines that have interesting findings. So I basically also accept guest contributions now, so people can submit their short stories. And I've already had, I think, 3 or 4 guest contributions, and it's super cool what people write about. And it's something that I would have never come up. And this way you also get to experience different writing styles and different short story authors, which I think is really cool.
Yep. Where can our audience find you or find your projects?
Yes. So right now it's still located on my website. So helenahartmann.com/science and fiction all together. But if you go on my website, you also find it under outreach. And I think we can link it below in the episode info.
Yes,
and I think,
of course,
this is basically an open call to everybody who's interested in writing to contact me, to have a look at it. And if you want to contribute, to let me know or submit an idea or a story directly.
Yes, the more SciComm projects, the merrier. We also have a bunch of these writing projects at the Science Basement. If people are interested, you have found your way to our podcast, but we also have a blog, Blogging Science, and a SciCrisp, where people can write their or summarize their thesis or research article in a short story format as well. I think it's a slightly different angle, but
maybe I can go and have a look, because I mean, I wrote a thesis once. I need to have a look at it again, maybe.
Yes, definitely. Let's cross-pollinate. What about your future plans, both for your research and for your SciComm?
Yeah, so as we already said a lot, I really would like to do a study with patients. I'm currently trying to prepare that and do some research, how people with chronic pain feel empathy, and how they feel it maybe differently from people without chronic pain. So that's going to be something coming up that I think is, I hope it's going to be really cool. And regarding science communication, I really want to try and think about different target groups. For example, children. I've done one children university workshop where I did some cool experiments with the children, and they really liked it. And so next year I'll do the junior university here in Essen. And the workshop is called something like, let's see what your brain can do. And there's going to be brain quizzes, and it's really tailored to that young audience. So I like that challenge, because it really makes me have to break it down even further than I already do. I think that's always good to challenge yourself and try new target groups, new techniques, and see where you find your niche of what you like.
And I think children often ask some of the most thought-provoking questions as well.
Okay, then I think we can wrap up the episode. Yeah, it was great having you, Helena. As we come to the end of this episode, what is one take-home message that you would like our audience to
Yes.
remember?
So that sounds very spontaneous now, but of course I had a little bit of time to think about that. So for me, and we touched on that during the episode as well, science is a learning process. So I'm also constantly still improving and learning how to do it properly. And all we do as scientists kind of to gather evidence about how the world works. So my take-home message is science is definitely not perfect. We're always trying to make it better and collect more evidence and find out more about how everything works. But I think this realistic angle also helps me to do research, because it's not this idealistic in the clouds, everything is perfect. It's a learning process.
That was a great summary of research in general, I think.
That brings us to the fun fact. Katya, what do you have for us?
Okay, so my fun fact for today is not so much related to pain perception as to time perception. So when you blink more, your time perception actually ends up being slower. And there's a very cool study about this, which we'll also link in the episode description. But they basically found that blinking in a way acts like a curtain coming down at the end of a theater scene. So the more scenes you basically take, the slower your time perception becomes. Whereas if you blink less, you perceive time to be going faster.
That's super interesting. I wonder if it's related to that if you want to relax, you also close your eyes, like you close the curtain.
Oh, yeah, they did. So they did actually, and for full transparency, I did find this a fun fact from another episode, from another podcast, the Andrew Huberman podcast. And he did talk also about sleeping and how our time perception during sleeping goes very differently.
Is that why my naps are never long enough?
Probably. Yes. But yeah, we'll link the study and then we can read more about it. But that was my fun fact for today.
Thank you, Katya, for that really fun fact. Really fun fact. And and thank you, Helena, for joining us on today's episode. It was really lovely to have you. All the best for your current and future research. And if you want to be interviewed, please drop us a mail at podcast@thesciencebasement.org. And until next time.
Thanks. Bye-bye.
Thanks. Bye.
The Science Basement.